Okay, chapter 10.1 is on, let me find what it is called, radical expressions and functions. So here we're working with radicals, which are like my square root, my cube root, my fourth root, fifth root, etc. And what we're doing is simplifying. So what we're going to do is we're looking at the chapter review on page 766, and we have some problems we're going to work out together. Let's start with number 1. So the instructions say, find the indicated root or state the expression is not a real number. So this is the square root of 81. Now remember, the square root is the principal root. And I know it's the principal root because it was given to me as a square root, which means my answer should only be the positive answer. So the square root of 81 is positive 9. Good. Number 2. It says the negative square root of 1 over 100. Well, again, this piece right here is the principal square root. One second. This is the principal square root. So this piece is going to give me a positive answer. But remember, there's a negative on the outside. So it's going to actually become a negative answer. So this becomes negative, and the square root of 1 over 100, use your calculator, and you find out it's 1/10. So it's negative 1/10. All right, number 5, let's see. The fifth root of negative 32. All right, well, again, use your calculators, and it'll come out to be negative 2. So really, if I'm using numbers and it's asking me for some type of root, we're allowed to use our calculator, so that should be straightforward. If you have questions on how to use your calculators, let me know. All right, number 7, last one. It says, find the indicated function value for each function, if necessary, round to 2 decimal places. And it tells me that g of x is equal to the cube root of 4x minus 8. And it wants me to find g of 4, g of 0, and g of negative 14. Well, again, it wants me to basically evaluate. And remember, what does evaluate mean? Plug in x. Well, here, x is going to be 4, so I'm going to plug x in for, plug 4 in for x, so I have the cube root. Well, 4 times 4 is 16, minus 8 is 8. And I'm going to let you finish that with your calculator. G of 0, well, the same thing. Everywhere I see an x, I'm going to put a 0, so it becomes the cube root of negative 8. And again, I'll let you finish it with your calculator. And then the last one is g of negative 14. Well, that's the cube root of 4 times negative 14 minus 8, which is the cube root of negative, that is 56, 64. And again, use your calculators to finish it. All right, let's continue. What else are we going to work on? Let's look at number 8. It says find the domain. So now, instead of actually evaluating our expressions, now we're actually concerned with the function part. Before, they were just regular values, numbers. Now they're actually functions. And again, we get back to domain. So let's write down the problem. It says f of x is equal to the square root of x minus 2. And it wants me to find the domain. So remember, the domain, let's change colors. The domain is the set of all x values that make the function valid. Don't mind my scribble. Now, what do I mean by valid? It means if I plug in an x value, I'll get some number back. It won't tell me error, basically. I'll be allowed to get an answer back. So when I think about square roots, the one thing you gotta remember about square roots is you cannot take the negative of square root. So you cannot take the negatives, or you cannot take the square root of a negative. I totally got that backwards, I'm sorry. So you cannot take the square root of a negative. So you want to avoid all kinds of negatives altogether. And then, so what you're going to do when you're finding the domain, the first thing you want to do is set your inside, which I call the argument. So set the argument greater than or equal to 0. Greater than or equal to 0. So basically I'm saying it can be 0 and it can be positive. And then you basically solve for x. So x is greater than or equal to 2. So the domain consists of all the x's that are greater than or equal to 2. This is the solution form of the answer. You can give it to me on a number line. So if I put on a number line, there's my 2. It has the equal sign. So that means greater than or equal. So because of the equal sign at the bottom, I have to use brackets. Now the question is, does it face to the left or to the right? Well, it says x is greater than, so I'm facing to the right. And I'm shading all of this and putting the arrow. Okay? So solution form, interval form, solution form, graph form, and then I can do the interval. Well, this is going all the way to the right, so it's approaching who? That'll be negative infinity. So I actually have the interval right there. The interval is bracket 2, comma, infinity. Good. Great. Awesome. So I have solution form, graph form, interval form, and then last I can do set builder notation. So the set containing x such that x is greater than or equal to 2. Awesome. Alright, so let's see. I'm also supposed to do number 9, which is also a domain problem, so I'm going to skip that one since we just did one like it. Number 10, simplify each expression. So let's see. Number 10, it says simplify each expression. So I have the square root of 25x squared. Well, let's rewrite the inside so everything is written to a power of 2. And remember, you always want to write it to whatever power is on the outside right here. This is the invisible 2, so I want to write everything so it's squared. So again, I have the square root of 25, well that is 5 squared, and then x squared is the same as saying x squared. Okay? So then remember, the square and the square root, they cancel each other out, and that leaves me with the 5 and the x. But remember, since it's a square root, I want the positive. So you have to put absolute values on your x. So if it's an even root, like, 2, then you have to have absolute values. If it's odd, then you don't. Alright, let's look at number 15. It has the fifth root of negative 32, x plus 7, all to the fifth power. All to the fifth power. Alright, let's see here. Well, again, we said we want to write the inside, so it's everything raised to the fifth power. So I have the fifth root. Well, that's going to be negative 2 raised to the fifth power. And if you don't know that, you can just, in your calculator, do the fifth root of negative 32. You'll see it's negative 2. And this piece right here is already set up, x plus 7 to the fifth power. Well, the fifth power and the fifth root, they cancel out. And I'm left with just negative 2, x plus 7. Now, since this is an odd root, I don't have to use absolute values. If it was even, I would have to put absolute values on everything. Okay, so we want to be careful with that. Alright, so that's 10.1. Let me know if you have any questions.